Good morning students, welcome back to Sheba online class. In the previous class we have studied geometrical interpretation and locus of the complex number. Today we go for the new heading, equation of complex form of a circle. And this is of the form modulus z minus z naught equal to r. Here z naught is center and r is the radius. Suppose modulus z minus z naught less than r means the points represents interior to the circle, maybe the points lying inside the circle, and if modulus z minus z naught greater than r implies the points represents exterior to the circle, that means it lying outside the circle. Understood? Next we are going to see the same exercise 2.6 fourth one. Fourth one is show that the following equation represent a circle and find its center and radius. First we have to form in the form of modulus z minus z naught equal to r. So that is modulus z minus, so taking minus outside, inside we get 2 plus I, isn't it? So signs are changed, minus 2 become plus 2 and minus I becomes plus I. So modulus of z minus 2 plus I equal to 3. And this is of the form modulus z minus z naught equal to r, isn't it? So it is of the form mod z minus z naught equal to r. And so it represents a circle. So it represents a circle. And what is the radius and center? Here center is this 2 plus I and radius is 3. Therefore, its center is 2 plus I and radius is 3. Understood? Let us see second subdivision. Modulus of 2z plus 2 minus 4i equal to 2. Listen, here the z coefficient is 2, but we want z coefficient is 1. Isn't it? Z minus z naught form. So we take this 2 outside, we get z plus 1 minus 2i equal to 2. Now cancelling these 2, cancel, we get z plus 1 minus 2i equal to 1. Now we form this as z minus z naught, modulus of z minus z naught. So z minus, taking minus outside, we get plus 1 becomes minus 1 and minus 2i becomes plus 2i equal to 1. Now this is of the form what? Z minus z naught equal to r, isn't it? So it is of the form mod z minus z naught equal to r, and so it represents a circle, isn't it? It represents a circle and therefore its center is what? Center is minus 1 plus 2i. 2i and radius is 1. Understood this? Listen the fifth one. Fifth second subdivision, mod z minus 4 whole square minus mod z minus 1 whole square equal to 16, and it is given z equal to x plus iy, and obtain the Cartesian form of the equation or locus of the equation. These two are same only. So first what is given? It is given z equal to x plus iy. Same. We are using this in this equation. We get. So therefore mod z minus 4 the whole square minus mod z minus 1 the whole square equal to 16. Substituting here we get x plus iy minus 4 whole square modulus minus modulus of x plus iy minus 1 the whole square equal to 16. Now collect the real part and imaginary part separately. Here real parts are x and minus 4. and imaginary part is iy modulus square minus modulus x minus 1 plus iy whole square equal to 16. Now modulus becomes root of real part square plus imaginary part square, and modulus square is given, so square root gets cancelled. We get x minus 4 the whole square plus y square and minus, right in bracket, x minus 1 whole square plus y square. There are two terms, so we put bracket. This minus is common to both, isn't it? So put bracket equal to 16. Now we expand this using the formula a minus b whole square. We get x square minus 4 2s are 8x plus 16 plus y square minus, right in bracket, x minus 1 whole square is x square minus 2x plus 1 plus y square equal to 16. Now listen, x square minus 8x plus 16 plus y square. Now multiplying minus inside we get minus x square plus 2x minus 1 minus y square equal to 16. So x square minus x square gets cancelled, y square minus y square gets cancelled, and write the remaining one minus 8x plus 2x and plus 16 minus 1, and bring this minus 16 left hand side, it becomes minus 16 equal to 0. Now plus and minus gets cancelled. We get minus 8x plus 2x is minus 6x minus 1 equal to 0. Multiplying throughout by minus 1, we get x 6x plus 1 equal to 0. This is our required equation. Required Cartesian equation is 6x plus 1 equal to 0. Is it clear? Next we go for new heading, polar form. Polar form, the complex number is denoted by z equal to r into cos theta plus I sin theta. Here z is x plus iy and r equal to mod z. Here r is the modulus of z and this is equal to square root of x square plus y square, and tan theta equal to y by x. From this we have to find theta, and for convenient we write this as r cis theta. Cis theta means cos theta plus I sin theta. Okay, and theta lies between minus pi to plus pi. And suppose our argument means theta lies in the first quadrant. First quadrant la irukkudu appadina, suppose alpha make with x axis, angle is alpha, make with x axis, that is this is also theta. நம்ம பாசிட்டிவ் டைரக்ஷன் ஆஃப் எக்ஸ் ஆக்சிஸோட எவ்வளோ மேக் பண்ணுதோ தட் இஸ் அவர் தீட்டா. ஸோ தீட்டா இஸ் ஆல்ஃபா ஹியர். சப்போஸ் இட் லைஸ் இன் செகண்ட் குவாட்ரண்ட் and this is given, this is alpha given, this is the negative direction. So we want positive direction. What is this? This is pi minus alpha, isn't it? So this is our theta. So theta is what? Pi minus alpha. Okay, next suppose it lies in third quadrant. This is third quadrant. Third quadrant also it is given, make with negative of the x axis. This is alpha, but we want this positive direction, and also this is clockwise direction, isn't it? Clockwise direction means we use minus. Actually this is pi minus alpha, we use minus of pi minus alpha. This is the clockwise direction. In argument we use anti-clockwise direction. Anti-clockwise direction is positive, but it is given clockwise direction. So clockwise direction means we put one minus. So minus of pi minus alpha equal to minus pi plus alpha, that is alpha minus pi. So our theta is alpha minus pi. In the fourth quadrant, theta is minus alpha. Listen, this is clockwise direction, so we take theta is equal to minus alpha. Understood this? Next, the polar form is this, and r equal to mod z, and theta is argument of z, and argument of z is what? Tan inverse of y by x. Next properties in the polar form is argument of z1 into z2. Okay, argumentless some properties given. Argument of z1 into z2 equal to argument of z1 plus argument of z2. And argument of z1 by z2 equal to argument of z1 minus argument of z2, and argument of z power n equal to n into argument of z. This is same as law of log, isn't it? The last one is cos theta plus I sin theta equal to cos of 2k pi plus theta. Theta is the principal value. We can add 2k pi with theta plus I into sin of 2k pi plus theta. And this argument z equal to capital argument of z, this is the principal value, plus 2n pi, where n is the natural number, and 1i minus 1 minus I, instead we use the argument. This is the principal value. We can add 2n pi with this. So 2n pi plus 0 becomes 2n pi, and pi by 2 add panningna 2n pi plus pi by 2, and here 2n pi plus pi, 2n pi minus pi by 2. Remember this, it's important one. And the next term in the complex plane, this is real part and imaginary part. In the first quadrant theta is alpha, and in the second quadrant theta is pi minus alpha. In the third one theta is alpha minus pi, and fourth quadrant theta is minus alpha. Okay, this is the positive real, and this is the negative real line, and this is the positive imaginary, and this is negative imaginary. And if suppose real part positive, imaginary part also positive, means it lies in first quadrant. Suppose real part negative, imaginary part positive, means it lies in second quadrant, and both are negative, it lies in the third quadrant, and real part is positive and imaginary part is negative, means it lies in fourth quadrant. So, and these four thetas are the principal arguments. And listen, the first sum in 2.7, write in polar form. Polar form is r into cos theta plus I sin theta. So, we write this as 2 plus I 2 root 3 equal to x plus iy equal to polar form is r into cos theta plus I sin theta. Okay. Next, find r. What is r? R is mod z, and which is equal to square root of x square plus y square, and this is x. X is 2 and y is what? 2 into root 3. So, substituting, we get 2 square plus 2 root 3 whole square, square root. This is 4 and this is 4 into 3 equal to 4 plus 12. So, square root of 16 we get equal to 4. So, this is our r value, modulus of z. Okay. And next we have to find alpha. Alpha is tan inverse of modulus y by x. This is equal to tan inverse of modulus, what is y? Y is 2 root 3 and x is 2. Cancelling, we get tan inverse of mod root 3, and this is the tan 60 degree. Tan 60. Said tan 60 is pi by 3. So, our alpha is pi by 3. So, first find the principal value. How to find principal value? Principal value find out pannanuna. First find it lies in which quadrant. This complex number lies in which quadrant. Listen, this is positive. Our real part is positive and imaginary part is also positive. So, plus plus lies in first quadrant. That's it. So, first quadrant means theta equal to alpha. Since our 2 plus I 2 root 3, this complex number lies in first quadrant. So, the principal value is principal value is what? Theta is equal to alpha. Theta is equal to alpha is what? Alpha is pi by 3. Alpha is pi by 3. First you have to substitute here. R equal to 4 and theta is equal to pi by 3 and then add 2k pi with this theta. And therefore 2 plus I into 2 root 3 equal to, instead R we use 4 and then into cos of theta is pi by 3 plus 2k pi plus I sin of pi by 3 plus 2k pi. Okay, which is the required polar form. Required polar form, and k is what? K is the positive integer or k is belongs to z. Integers sollala. K belongs to any integer. Understood? Listen how to find polar form. This is given 2 plus I 2 into root 3. First let us take this given complex number equal to x plus iy equal to the polar form, that is r into cos theta plus I sin theta. We want r and theta value. How to find r? R is mod z. Mod z equal to square root of real part square plus imaginary part square. That is 2 square plus 2 root 3 whole square. We get 4 plus 4 into 3. That is root 16, which is equal to 4. So we got the value r. Next we have to find alpha. Alpha is tan inverse of mod y by x. So y is 2 root 3 by 2. 2 gets cancelled, we get root 3. So root 3, tan oda endha value root 3 varum check pandrom. That is tan of 60 degree. And we get 60 is pi by 3. 60 degree is what? Pi by 3. And alpha equal to pi by 3. And next we have to find this complex number belongs to which quadrant. Listen, the first real part and this is imaginary part. Both parts are positive, that means plus plus. So it lies in first quadrant. Okay, it lies in first quadrant. So after finding the quadrant, we use the principal value. Principal value means first quadrant means theta equal to alpha. Suppose we get third quadrant means theta is equal to alpha minus pi. Okay, finding theta value. After finding this, we have to write in polar form. Polar form is r into cos of theta plus 2k pi. What is theta? Pi by 3 plus 2k pi, and the sin of pi by 3 plus 2k pi, where k is belongs to the integer. This is our required polar form. Understood this? I hope you all understood today's class, and do the homework and revise the example sums also. Okay, thank you.